Hello everybody, welcome to your Section 8 Chem Talk. You should have your green sheet out and open to Section 8. It's titled Flame Tests, Identifying Metals. So pause the video if you need to so you can find your green sheet so we can get started. We're going to start at the top where it says parts of an atom. Hopefully this is somewhat of a review. I'm sure you have talked about these different aspects of an atom, whether in elementary, middle school, or even last year in biology or physics. Right, so, an atom consists of three parts. These three parts are a proton. Proton is the positively charged particle found in the nucleus. Our nucleus is the center of the atom, right, and that's where we find almost 100% of the mass of our atom is in the nucleus. The neutron is the neutral particle found in the nucleus. Right, these neutrons basically act as a glue holding the protons together in the nucleus. Right, because if all of these protons in the nucleus are positive, right, I'm sure you've heard the phrase that opposite charges attract and like charges repel. So if all of the charges in the nucleus have the same charge, they're going to want to repel from each other. So we need a neutron in there to hold it together, or many neutrons in there to hold them together. And lastly, we have an electron. And electrons are the smallest of our particles, and they travel around the outside, right, of our atom. And these are negatively charged particles, right? Again, found outside the nucleus. Right? If you can imagine an atom like the solar system, the nucleus would be like our sun, the star in the middle that has most of the mass of our solar system, and an electron would be like not even like a planet. It would be more like an asteroid shooting outside in the solar system, right? It's very, very small, moving very fast, and holds a negative charge. And even though electrons are significantly smaller than protons, their charges are equal and opposite. So the charge of one proton, right, is a positive one charge, and the charge of one electron is a negative one charge. Right? They would be able to cancel each other out. All right, so here's a picture of a carbon atom. Right? Imagine we're very, very small, 340 picometers. A picometer is 1/billionth of a meter, so very, very small. And in this carbon atom, right, if we're looking at the subatomic view, so even smaller than an atom, right, you would see your nucleus filled with the 6 protons and 6 neutrons on the inside, and then we would be surrounding by different levels of electrons. Okay, and we're going to be talking more about those levels in today's video. All right, but you can see electrons on the outside of the nucleus with a negative charge, protons and neutrons inside the nucleus. Okay, with protons having a positive charge and neutrons having no charge, they are neutral. All right, so let's focus in on some electrons here, right? Because that's going to be one of the main points of our section here. So electrons, we talked about, they have a negative charge. When an atom gains or loses an electron, we now call that atom an ion. So an ion is just an atom with a charge. If we gain an electron, we get a negative ion, or the ion has a negative charge. If we lose an electron, right, the ion now has a positive charge, or we form a positive ion. You might think of this kind of like a negative friend in your friend group, right? When you are around that friend, right, you might become more negative, right, because they have that negative influence or a negative charge like an electron. But while this person's away, right, you might feel overall more positive. Right? So as you lose an electron, we get a positive charge. As we gain electrons, we get a negative charge. All right, so here's a diagram down here at the bottom. We have, it looks like 3 protons and 3 neutrons in the nucleus, surrounded by 3 electrons. Because we have 3 protons, right, 3 positive charges, and 3 electrons, 3 negative charges, our atom is neutral. But when we lose an electron, we now have 3 protons, giving us a positive 3 charge, and 2 electrons, giving us a negative 2 charge, for a total charge of positive 1. Alright, so determining the charge of an ion is simply a matter of comparing the amount of electrons we have to the amount of protons we have. Alrighty. Now, one of the big things we're going to talk about in this section is what's called the flame test. Okay, so you should see this diagrammed at the bottom. The one at the bottom left we're going to talk about first is called the ground state. So make sure you're filling in the blank there. We're labeling this diagram as the ground state. Alright, so on this ground state diagram, we have an electron, and the electron should be in constant movement around the nucleus. So we'll represent that by this blue dot moving around. And you see these different circles here around our nucleus. These are our energy levels. So the first circle will be energy level 1, second circle will be energy level 2, and lastly we would have energy level 3, right? We can have more than 3 possible energy levels. That is okay. But the first circle outside of the nucleus will always have to be energy level 1. Alright, and the major idea here is that as our atom absorbs energy, right, you can see that we have some energy coming into our atom, our electron is able to jump up an energy level. Okay. Now, on the right diagram you have at the bottom right of your green sheet is the excited state, so make sure you're writing that in here as well. So after our atom has absorbed energy, we can now see it's traveling along the second energy level. Right? In order to release energy and for us to see light and color, we need to release energy. So, take a look here, we have some energy leaving our atom, and now our electron has jumped back down to the bottom energy level. Okay, so in order for an electron to jump up an energy level, we need to absorb energy, and in order for an electron to fall down an energy level, we need to release energy. Right? It's kind of like yourself preparing for a sporting event through the day. So if you know you have a football game or a soccer game after school, it's important that you are eating a healthy breakfast in the morning so that you can absorb that energy, right, and have more energy for your game later. Alright, and so we were just looking at the nanoview of what would be happening during a flame test, and that's what we're going to be doing during our investigate in class, is doing the flame test. One of my favorite investigate activities we get to do throughout the semester. So let's talk a little bit about the flame test and what's happening. Right, so when metal ions are placed in a flame, right, so we're going to be putting salts on a wooden stirrer and just holding that over the Bunsen burner for a second at a time. Right, so when we place it over a flame, the electrons absorb that energy and move up to a higher state. So as the heat is causing our particles in there to move faster, right, those electrons are jumping up an energy level, right, moving to a higher excited state. Right. And then almost simultaneously, because we do not see this process happen slowly, it happens at the same time for us. But when the electrons fall back down, they release an energy and they give off a color of light. And this might be why you see different colors for fireworks, or maybe you've bought one of those pack of salts that you can throw in your fire pit to make it look like it has different colors. Okay, so when metal ions are placed in a flame, the electrons absorb energy and move to a higher energy state. And then, again, almost simultaneously, these electrons will fall back down and release energy, giving off color and light. All right, so the color of our light depends on, right, the amount of energy released. So how far down are we jumping energy level wise? Are we jumping from energy level 2 to energy level 1? Or are we jumping from energy level 4 to energy level 2? Right? Different jump downs are going to release different colors. Right, so the energy released equals the energy at the excited state minus the energy at the ground level. Right? And you might want to star this. There's a question in your Chem to Go that's going to have to, or that you will have to use this little formula here in order to answer, and you will see a similar problem like that on your Section 8 quiz. So I would definitely put a star next to that one. Every element has a different electron, or has different electron energy levels. So if we are doing a flame test with magnesium, right, there will be different electron energy levels than if we're using an element like calcium. And this is why every element gives off a different color of light. Right, so, and you will see in class what elements give off what colors. And sometimes there's even some other effects that we will see. Alrighty, so that should end the Section 8 Chem Talk. Pretty quick one. Quick as in 11 minutes, so we didn't take up the whole 15 minutes. Make sure you're checking the rest of your daily agenda, completing everything you have for today, so you are ready to knock our lab out of the park when you get back to class. All right, see you guys.